We talked earlier about how graphs are really a specialized type of model. It's a visual representation used to show the relationship between sets of quantitative data. Different graphs are more useful to use in different circumstances. So for instance, if I'm relating the dependent variable to my independent variable, it might be appropriate to use a bar graph or a histogram. However, if I'm working with percentages, sometimes it's more appropriate to use a pie chart or a circle graph. And sometimes I'm working with numerical data as my dependent variable, and it's more appropriate to use a scatter plot. So we're going to talk about the situations in which we should be using these types of graphs to make our data make the most sense to the people that are going to be reading it. Pie charts is the most useful type of graph to use if you're dealing with percentages. So this is a summary of all the different types of electricity production in the United States. All of it is out of 100%, and this would be a good situation to use a circle graph. A bar graph is really the most useful type of graph if we're dealing with quantitative data as our dependent variable and as our independent variable. We're dealing with types or categories of things. So in this case, I'm dealing with the trash that's collected on a beach, and there are very clear-cut categories on my x-axis. And all of these things are my independent variable, but they're not quantities. This is the best situation to use a bar graph. However, a line graph can oftentimes be more useful if I have both my independent variable and my dependent variable expressing quantities, so I can map them on a Cartesian plane such as this. We're going to talk in a second here about trend lines, right? These trend lines can oftentimes show us the relationship between all of the data points. A good graph should have a label on each axis. If there's appropriate units, they should be there as well. There should be a title. And then sometimes I can construct a trend line. There's two ways that I can make predictions based on my data. Extrapolation. X means outside. If I want to predict in what direction my data would be going outside of what I actually collected, that would be extrapolation. Interpolation is using the pattern found within the data set itself. So if I follow the bounds of my data collected here, and I want to draw a trend line with all of those data sets taken into account, that would be interpolation. Extrapolation would be, okay, outside of the data set, where will this data go beyond the bounds of what I collected? Line of best fit is a way for us to show the relationship between the data that we collect. Now, a line of best fit does not have to touch every single data point, nor does it have to go through the origin of the graph. We're simply using this line as a way to show the relationship between my dependent variable and my independent variable. From here on out, we're going to talk a little bit more about scientific notation, and that will be in your next video.